right, so this is the Trig equations unit review. Here are your unit circle values for 1 through 9. They are going to be in some scrambled form of this on your quiz as well, because always and forever the unit circle is super important. So I want you to keep it in your brain, so I'm going to keep it coming at you on quizzes and tests. So hopefully you got those checked. If you didn't get those checked, go ahead and pause. I'm going to move on to number 1 and number 2. So for solving equations, I think a couple of things for you to look for. One, I would look for factoring. The second thing I would look for is, I would guess I want you to decide if you can factor or solve directly. Those are kind of the things I want you to look at there. Do you need to factor or can you solve directly? Just, move stuff around and solve directs. The second thing you want to look for is if you have squares. Do you need to use a Pythagorean identity? Every one of these is going to look a little different, but there is a lot of repetition here. If you've been doing all the practice all along, hopefully these will flow really nicely for you. Number 1 in this section, I see sine, tangent equals sine. It's really tempting to divide by sine, but if you do that, you lose a solution. Instead, I'm going to subtract sine over. Now, sine is not a like term with sine tangent. Sine is not a like term with sine tangent. That's like x, y, and x. So, or if you give it a, b, and a, you can't subtract those. We do have sine in common though, so we can GCF a sine out. Remember, when you're taking your GCF, the number of terms that you started with are the number of terms that should be in your parentheses. So here, I factored out the sine, so I have a tangent left here, minus, I factored out the sine, so I have a 1 left there. That 1 is a really common miss there, so make sure you have that 1 as a placeholder. Factoring is just, especially GCF, I think it's really easy to think of GCF as fancy division. When you divide by sine, what's left? That's what you're doing to make that happen. Now we can set both of these equal to 0 and solve. Remember, we have to be set equal to 0 in order to factor legally. And now we think, now does the unit circle work? Unit circle backwards. Where on the unit circle does this happen? Well, for sine, sine is 0 at 0 and pi. And tangent is 1 at pi over 4. Tangent's also positive 1 in the third quadrant. So your third quadrant, pi over 4, is 5 pi over 4. So if you're not doing the extension, you're done with that problem. If you are doing the extension because your goal is to get above a 92 on this quiz, then now we draw our little diagrams. So 0 and pi are pi apart. So to get all the coterminal angles for 0 and pi, we write this little equation, 0 plus pi k. That gets 0 and pi taken care of. For 5 pi over 4 and pi over 4 is right in the middle of the first quadrant. 5 pi over 4 is right in the middle of the third quadrant, so those are also pi apart. So to get all your coterminal angles there, we're going to do 5 pi over 4 plus pi k, and that's going to get both of those. Again, that's the extension. If that was not your goal, you can kind of ignore that piece. All right, GCF is a big deal with these. So there's number 2 is another GCF problem. And dividing by cotangent, we're subtracting it over. I guess I didn't talk about that at the end of the last problem. At the end of number 1, if we would have divided by sine, we would not have gotten the right answer for tangent. We would have ended up with tangent. I guess we would have ended up with tangent equals 1. So we would have gotten the right answer for tangent, but we would have lost our solutions that were with sine. So whenever you divide by a variable instead of subtracting and factoring, you're going to lose a solution. Don't do that. All right, for number 2, my 2 terms have cotangent in common. If I divide cotangent out of my first term, I'm left with 2 cosine of x. And if I divide cotangent out of my second term, I'm just left with 1. Remember, 1 is your placeholder for multiplication. So the way this looks is this. Now I can set both of these equal to 0, just like the last problem. Again, we have to be set equal to 0 to legally factor. I'm going to solve for cosine here first. I'm going to add 1 and divide by 2. And now we work the unit circle. I think cosine's a little easier to think through, so I'm going to think through cosine first. In the first quadrant, cosine is 1/2 at pi over 3. We're only looking for positive 1/2 here, so the other place that cosine is positive is quadrant 4. Our pi over 3 in quadrant 4 is 5 pi over 3. Cotangent is a little trickier to think through, especially with zeros. I think the zeros and undefined are the hardest for me. So instead of thinking cotangent equals 0, what I know is cotangent is cosine over sine. And in order to have 0 as our cotangent, I need 0 on top. If cosine is 0, then sine is either positive or negative 1. And now thinking through that ordered pair is easier for me. Thinking through this ordered pair is much easier for me than thinking about cotangent. So cosine is 0 and sine is 1 at pi over 2. The other place that happens, where cosine is negative 1, is at 3 pi over 2. So if you're not doing the extension, then you're done with this problem. If you are doing the extension to get more than a 92, now you're drawing the picture. Pi over 2 is right up here. 3 pi over 2 is straight down. Those two are pi apart. So to get all our coterminal angles, pi over 2 plus pi k. Pi over 3 and 5 pi over 3. Pi over 3 is in the first quadrant. 5 pi over 3 is in the fourth. Those are not pi apart. They don't make a straight line. They make that sideways V. So I have to write 2 equations for those. Pi over 3, I'm going to do plus 2 pi k. That gets us all the rotations that would be coterminal with pi over 3. And 5 pi over 3 plus 2 pi k gets us all the rotations that would be coterminal with 5 pi over 3. So that was your unit circle business. Double check on your first quadrant of your unit circle, and there's number 1 and number 2.